Hello, and welcome to Backer Breaks It Down. In this episode, we are going to explore arc length. Arc length is exactly what it sounds like. It is the length of an arc. So like in this comic here, the lady is saying, we also have pi over 3 radians pizza slices. Okay, so in our previous episode, we were talking about radians. And so like pi over 3 radians, like we can kind of imagine like what that would look like. And if you're still like, you don't think in terms of radians, you think best in terms of degrees, remember I can simply multiply radians by 180 over pi to get the equivalent degree measure. So we are talking about like this slice of pizza right here. Okay, so arc length in terms of pizza would be like the crust. How much crust is right there? Okay. So arc length in a circle of radius r. So if theta is the central angle in a circle of radius r, and theta is measured in radians, okay, then the length of the intercepted arc is given by s equals r times theta. So s is the arc length, r is the radius, and theta is the central angle in terms of radians. So if we are given an angle in degrees, we should convert that angle into radians before calculating the arc length. Okay, so in problems 8 and 9, we want to find the missing quantity. So S is the arc length, R is the radius, and the angle is theta. So in number 8, we're given R equals 2 inches, theta is 30 degrees, find S. Okay, so we have to kind of start with theta because our arc length formula is written in terms of radians. So I need to take the 30 degrees and I need to convert this into radians. So I need to multiply it by pi over 180. Okay, so before simplifying, I get 30 pi over 180, and then I can go and actually do the simplifying. I guess I really don't have to. I could just leave it like this because heck, I'm finding arc length, right? So yeah, why not just leave it like that? But 30 degrees in terms of radians is equal to 30 pi over 180. And so once theta is written in terms of radians, we can use our arc length formula. The arc length is S is equal to R, the radius, times theta. And so here we would have S is equal to the 2 inches times the 30 pi over 180. And then we can do the math to come up with the arc length. So I can multiply what's on top first. So I can go 2 times 30 pi, and that's going to be 60 pi over 180. Now, if I want an exact answer in simplified form, I would simplify the 60 over 180, and that's going to be like 1/3. So we're looking at pi or arc length is equal to 1/3 pi. Okay, and then of course the arc length is measured in the same units as the radius. So pi over 3 inches is what we're looking at. Okay, in number 9, we're given theta is equal to 1/3 radian, S is equal to 2 feet, find R. So a question that often comes up with this particular example is the theta. Like they're telling us is 1/3 radians. And so students often think like a radian has to have pi. Like it has to be there, and that's just not true. Like going back to number 8, if I actually calculated an approximation, I would get 1.05 inches here. Okay, I don't need to have the pi when they're giving me a radian measure. That's just the bottom line. Just like pretend like they already multiplied by pi. Okay, and they got a nice answer of 1/3. How nice is that? So we don't have to do anything with theta here. We can use it as is. It is 1/3 radian. They want us to find R. Well, we're working with a formula where arc length is equal to the radius times theta. And so whenever you're working with formulas, my advice is formula substitution solution. So start with the arc length, or start with the formula, plug in what you know. So 2 is equal to r times 1/3. And then once you see it on your paper, then you could be like, oh, so I need to like multiply both sides by 3, because it's all the denominator's fault with fractions, right? So if I multiply both sides by that denominator of 3, that fraction goes away. I get 6 is equal to r. So we're looking at 6 feet to be the radius of this circle that has an arc, whose radius measures 1/3 and whose arc length is 2 feet. Okay, but that's how we can find arc length when we're working. Well, we have to be working in radians. Theta is the angle in radians, but the arc length is equal to the radius times theta. And that's how Backer breaks it down.